Hello everyone, welcome to Math 115, College Algebra. So in this section, 7.3, we're going to talk about basically trig functions of any angle. So now we're not going to restrict ourselves to just an acute angle, right, by using right triangle trigonometry. We're going to actually learn how to compute the trig functions of any particular angle. Okay, and that's going to involve something called the unit circle, but I'll explain that more carefully. So let's start by, here, I'm going to draw another picture. Let me make some room here, slightly off to the right, where I have a circle, and I'm going to start with a circle of radius r. So here's my circle, and let's say the radius here is r. Okay, it's centered at 0, 0, has a radius r. And if I want to find the angle, remember that's measured from the positive x axis counterclockwise, right? So let's say this angle here is, I'll call it phi. So angle phi. So these coordinates right here on the circle, right, there's going to be an x value and a y value. And you can think of it as the x value is this distance, right, away, and the y value is going to be the vertical distance up. So this is kind of like the x, this is kind of like the y. So we're going to start by thinking about this in terms of right triangle trigonometry. Since we're in the first quadrant, that angle is between 0 and 90 degrees. So we can think of this as a right triangle. And we know the definition of the trig functions for a right triangle, right? We know that cosine of the angle phi is equal to the length of the adjacent side over the length of the hypotenuse. All right, we learned that in the last section. And the adjacent side in this case is the x, and the hypotenuse is the r, right? So in general, cosine of phi is going to be whatever x is divided by r. And then for sine of phi, it's going to be the opposite, the length of the opposite side divided by the hypotenuse. In this case, the opposite side is y over the hypotenuse, which is r. So I can write this as y over r. Okay. It turns out that this is going to be true for any angle that I choose. So if I have some angle, let me draw like a new angle, say here. Right? So now I'm starting at the positive x-axis and measuring counterclockwise. Let me call that theta. And again, these coordinates right here are going to be x and y. They're going to both be negative, right, because they happen to be in the third quadrant. But by definition, the cosine of the angle theta is still defined as x over r, where this, again, this radius is r. The r is always positive, right, because this is just the distance from the origin out to the circle. So the r is always positive, but then the x and y depends on what quadrant you're in, right? In the first quadrant, they're both positive, but like in this third quadrant here, they're both negative. In the second quadrant, the x would be negative and the y would be positive. In the third quadrant, the x is positive and the y is negative. So in this case, in the third quadrant, x is negative, r is always positive, so cosine of the angle is going to be a negative value. Okay, but by definition, cosine of theta is x over r. And same thing for sine. By definition, in general, it's going to be y over r. Okay, no matter what the angle is. You could even have an angle that goes around several times, right? It could be cosine of 300, let's say cosine of 500 degrees, right, where it goes around more than once. Or, cosine of 250 degrees. Whatever it is, it's defined to be x divided by r. Okay, we're going to focus on a unit circle. What does that mean? It means that r is equal to 1. Okay, so for a unit circle, means r is basically equal to 1. So unit just means like 1, right? So in this case, the radius is going to be 1. So I'll draw my circle. This radius is just 1. And again, right, I have my x and y values. So this is x, this is y. So cosine of the angle, let me call it alpha or something. Cosine of alpha is going to be the adjacent x over the hypotenuse, which in this case is 1. And then sine of alpha is going to be y over the hypotenuse, which is the radius, which is also 1. So this simplifies to basically saying that the x value, because I'm dividing by 1, right, I can say that x is equal to cosine of the angle and y is equal to sine of the angle. Like, by definition, that's going to be true for a unit circle. Okay, so let's go back to the original circle that was already drawn for us here. Let's see if we can answer these questions. It says, graph the cosine of theta equals 1/2 and sine of theta equals radical 3 over 2 on the unit circle above. Okay, so we know that this, first of all, it's a unit circle, so we know that this radius is equal to 1, right? The distance from here to here is going to be 1. And because of that, by definition, x is equal to the cosine of the angle, which in this case is 1/2, and y is equal to the sine of the angle, which in this case is radical 3 over 2. So I just have to plot x equals 1/2 and y equals radical 3 over 2. Well, x equals 1/2 is going to be here, right? And then radical 3 over 2, if you work that out, it'll be something a little less than 1, maybe right here. So if I plot that point on the circle right here, that's going to be the angle theta here, right? So these coordinates are 1/2 radical 3 over 2. Okay, so it's in the first quadrant, right, because both the x and y are positive. All right, what about the second example there? Graph cosine of alpha equals negative radical 2 over 2, and sine of alpha equals positive radical 2 over 2. Okay, so again, because this is a unit circle, this tells us that the x is equal to cosine alpha, so we know the x is equal to negative radical 2 over 2, and the y is equal to sine of alpha, that's going to be positive radical 2 over 2. So if I plot those, they're sort of pretty much like right here and maybe here. So this would be like the terminal side of that angle. The coordinates here would be negative radical 2 over 2, comma, radical 2 over 2. Right, and then this angle, I'll do it in green, this is the alpha. Okay, so cosine of alpha equals the x value, and sine of alpha equals the y value. Okay, let's do a few more of these around the entire circle so we get a better idea of what these particular values are. So let's try to find these. First one is cosine of 90 degrees and sine of 90 degrees. Here, I'm going to make this a little larger. So I'm going to draw at least part of a unit circle. So I have my coordinate system here. And this is the radius of, so this is like just part of the circle, radius of 1. So what is, if this is 90 degrees, right, so I went from there to there. What is this coordinate? Well, if it's a unit circle, the x value must be 0 and the y value must be 1, right? It's the full radius. But we know that cosine of the angle is always going to be the x value. So that's going to be 0. And then sine of the angle, in this case 90 degrees, is always going to be the y value. In that case, this is 1. So basically, this tells us that cosine of 90 degrees is equal to 0, and sine of 90 degrees is equal to 1. Okay, what about cosine of pi, sine of pi? So again, I'll start by drawing my unit circle. I'll just draw part of it. Well, remember what pi is, right? Again, I think more in terms of degrees myself, but pi is equivalent to 180 degrees, okay? So when we're talking pi radians, we're talking this angle here, from here all the way to here. So this angle would be pi radians. All right, but what is this coordinate here? Because we need, remember, we know that the cosine of pi radians is going to equal the x coordinate, and the sine of pi will equal the y coordinate. So what are those coordinates? What are the x and y coordinates at that point? Well, it's a unit circle, right? So this is length 1. So basically, the x value must be a negative 1, right? Because I'm moving to the left 1, and the y value is 0. So that means cosine of pi, which is equal to x, is equal to negative 1, and sine of pi, which is equal to y, which is equal to 0. Okay, what about cosine of 3/2 pi? So if you were to convert 3/2 pi into degrees, that's like 270 degrees, right? It's like 1.5 times pi. So remember, 1 times pi is 180. I have another half of pi, that's 90. So this is going to be like 270 degrees. So it'll look something like this. So this is the angle, 3 pi over 2, or 270 degrees, right? Same thing. So if I want to know the cosine of 3 pi over 2, that's going to be the x value at that point, and the sine of 3 pi over 2 is going to be the y value at that point. So what are the x and y values at that point right there? Well, again, this is a unit circle, right? So the x is just 0, right? Because I'm not moving at all on the x-axis. And then I need to move down 1 to get at that point. So the y is a negative 1. So it has coordinates 0, negative 1. So therefore, cosine of 3 pi over 2 is equal to 0. And sine of 3 pi over 2 is equal to negative 1. Okay, I think it only asked for cosine, but we did both of them. And then finally, what about sine of 0 degrees? So 0 degrees means the initial side and terminal side are the same, right? So if this is length 1 again, so I haven't really rotated at all, right, if it's 0 degrees, but we're still considering this to be a unit circle, so this is length 1. So this point has coordinates 1, 0. So that means, again, that cosine of 0 is equal to the x value, and sine of 0 is equal to the y value. So cosine of 0 degrees is equal to 1, and sine of 0 degrees is equal to 0. And by the way, I guess if I'm being careful, because there's no degree symbol here, this is also the same, also true for radians, right? So cosine of 0 radians is also 1. Sine of 0 radians is also 0. If I'm being careful, right, since there's no degree symbol, it's implied it's radians, but this is also true. Because 0 degrees is the same as 0 radians. So cosine of 0 is 1, sine of 0 is 0. All right. Let's talk now about something called the Pythagorean identity, which is related to the Pythagorean theorem, but involving trig functions. Okay, so again, just to remind you, remember the Pythagorean theorem. If you have a right triangle and the lengths of the two legs are, say, A and B, the length of the hypotenuse is C, then the Pythagorean theorem says that the length of one leg squared, A squared, plus the length of the other leg squared, B squared, is equal to the length of the hypotenuse squared, right? C squared. So A squared plus B squared equals C squared. Okay, so if we have a unit circle, and I have some angle, I'll just kind of draw it randomly so it's like in a second quadrant. So this is my angle, call it theta. We know this length is 1, and these coordinates are going to be x and y, which means that this length right here is x, and this length right, that height is y. Right, so if I use the Pythagorean theorem on this, even though x is negative, it still works, right, because I can square the value. So I can say x squared plus y squared is equal to 1 in this case, right? Because my hypotenuse has length 1. I'm kind of extracting out that triangle from the picture, where this is x, this is y, this is 1, right? So I have x squared plus y squared equals 1. But with a unit circle, we just defined x to be equal to cosine of theta, and y is equal to sine of theta. So I really have cosine of theta squared, that's my x squared, plus sine of theta squared is equal to 1. And then the way that you write cosine of theta squared, a shorthand notation is to write it like this: cosine squared of theta. That means the same thing as cosine of theta squared plus sine squared of theta is equal to 1. Okay, so this is the key thing that we're after, the Pythagorean identity. But let me just remind you, so you're going to write cosine of theta all squared. Shorthand notation is cosine squared of theta. They mean exactly the same thing. And same thing with sine. If I do sine of theta squared, that's sine squared of theta. Okay, that's how you want to interpret it. Okay, so sometimes this is useful, the Pythagorean identity here, if they give us the value for either the sine or cosine, we're asked to find the other one. But because the signs change depending on what quadrant you're in, then we have to be told like what quadrant the particular angle is in. So let's do some problems with this. All right, let's say we're told if sine of t, so t is the angle in this case, is equal to 3/7, and t is in quadrant 2, find cosine of t. Okay, so we can actually go right to the Pythagorean identity. We know that cosine squared of t plus sine squared of t is equal to 1, right, by the Pythagorean identity. And we're told that sine of t is 3/7. So this says that cosine squared of t plus, remember the way to think about sine squared of t means sine of t all squared, but sine of t is 3/7. So this is 3/7 squared is equal to 1. If you multiply that out, right, this is 9 over 49, I guess. Yeah, 9 over 49 is equal to 1. And then if I subtract 9 over 49 from both sides, well, on the right-hand side, right, I have this now. I have cosine squared of t equals 1 minus 9 over 49. But I can rewrite 1 as 49 over 49 because I want the same denominator, right? So I can subtract them. So this is 49 over 49 minus 9 over 49. And what is that? Well, that's going to be 40 over 49. And then how do I get cosine of t by itself? If I have cosine of t squared, remember this notation, cosine squared of t means cosine of t squared. Here, I'll even write it that way. Right, that means this. I need to take the square root of both sides. But when you do that, don't forget it's going to be plus or minus, right? So I'm going to have cosine of t. So cosine of the square root of cosine of t squared is just cosine of t. That's what I wanted. Equals plus or minus the square root of 40 over 49, which is the same as the square root of 40 over the square root of 49. And we can simplify that a little bit, right? We know that, here, let's think about it this way. If I do square root of 40, if I find the prime factorization, you kind of do this in your head. This is 2 times 20, right? 2 times 10, 2 times 5. This is going to be, I can pull out a single 2, and I'm left with a radical 10, I guess. And then square root of 49 is exactly 7. So I have cosine of t equals plus or minus 2 radical 10 over 7. Okay, but the question is, which one do I take? Do I take the positive or the negative? And here's the key thing. We're told that the angle is in quadrant 2. Okay? So if you think about what's going on with the different quadrants, I'll draw Cartesian system here. In quadrant 1, all the trig functions are going to be positive. So I'll just remind you, like sine is positive, cosine is positive, and tangent. When we talk about tangent, tangent is also positive. How do I know that? Because remember, sine is going to be y divided by r. R is always positive, and y is positive in the first quadrant. Cosine is x divided by r. X is positive in the first quadrant. R is always positive. And tangent is y divided by x, and they're both positive in the first quadrant. Right? So those trig functions are all positive. In the second quadrant, here y is positive, but x is negative. So that means sine is positive. That's okay. Cosine, because it's x over r, is going to be negative. And in tangent, because it's y divided by x, is also going to be negative. In the third quadrant, both x and y are negative. So that means sine is going to be negative. Cosine is going to be negative. But tangent, because it's y divided by x, is going to be positive. And in the fourth quadrant, x is positive, y is negative. That means sine is negative. Cosine is positive. And tangent is positive. Okay, how do you remember that? The way I learned this was all students take calculus, but there's other mnemonics you could also use. So Here, I'll just write a few of them. So all students take calculus. And you could probably look this up or have AI come up with some new ones for you. What this means is if you start in the first quadrant, right? The A here, the all, reminds you that all of the trig functions are positive. Okay, so this is going to remind you which ones are positive. So the first quadrant, all are positive. Then I go counterclockwise. I go to quadrant 2. In quadrant 2, the sign is positive. The other two are negative. In quadrant 3, the tangent is positive. The other two are negative. And in quadrant 4, the cosine is positive and the other two are negative. So I think I have an error here. Hold on. Yeah, this tangent should be negative here, right? Because it's y divided by x. And the y is negative, the x is positive. So calculus, so cosine is positive, tangent is negative. Another mnemonic that I found was add sugar to coffee. Again, it's silly, but it helps you remember, right? Again, the A is quadrant 1. All the trig functions are positive. The S is quadrant 2. It's saying the sign is positive. The other two are negative. The T says in quadrant 3 that the tangent is positive. The other two are negative. And in the coffee, the C reminds you that cosine is positive. The other two are negative. Okay. Here, let's do another example. If cosine of 24 25ths, if cosine of t equals 24 25ths, and t is in quadrant 4, find sine of t. Okay, so again, let's use the Pythagorean identity to do this. So I have cosine squared of t plus sine squared of t is equal to 1. And we're told cosine of t is 24 25ths. So 24 divided by 25 squared plus sine squared of t is equal to 1. I can expand that out, right? This is 576 divided by 625 plus sine squared of t is equal to 1. I can subtract this term from both sides. So minus 576 over 625. And I'm going to get that sine squared of t is equal to, if you work this out, right? So again, you need to rewrite 1 as 625 over 625. And you're going to end up with 49 over 625. Okay, so I did that subtraction here, right? I did 1 minus this. So 1 is 625 over 625 minus 576 over 625. 625 minus 576 is 49 divided by 625, right? I keep the denominator. Okay, now I need to take the square root of both sides. Because remember, sine squared of t means this, means sine of t squared, right? So I take the square root of both sides. Let me write that better. And remember, it's plus or minus. Okay, so I end up with sine of t, that's what I wanted, plus or minus, and it turns out the square root of 49 is just 7, and the square root of 625 is 25. So it's plus or minus 7/25. Okay, but which one? Which one do I choose? Well, we're told that the angle was in the 4th quadrant. So if the angle is in the 4th quadrant, right, what's true about sine? sine is negative, right? All students take calculus or add sugar to coffee. In the fourth quadrant, cosine is positive, the other two are negative, so sine is negative. So therefore, the correct answer here will be sine of t is equal to negative 7/25. So that would be my answer. Okay, so we need to be told like what quadrant the angle is actually in, because there's going to be like two quadrants that could give you the correct answer, right? You need to know like what quadrant the angle is actually in to reduce it to one particular value, because it could be positive or negative. All right, special angles. There's some special angles that you should be familiar with. I've mentioned some of these before, but let me give you some ways of thinking about this using some special triangles. This is the way I always think about this. So the first one is something called a 45, 45, 90 right triangle. So if I have a right triangle, this is also called an isosceles right triangle because the lengths of the two sides are the same. So let's assume that this is 45 degrees, which means this has to be 45, right? If the other side is 90, because they all have to add up to 180. So these two have to add up to 90. And let's just call this length 1, which means this is the same one. And then if I want to figure out the length of the hypotenuse, I could use Pythagorean theorem, right? So I have 1 squared plus 1 squared is going to be 2, and I want the square root of that, right, for that side. So this is the square root of 2. So we know that cosine, I'm just using right triangle trig now, cosine of 45 is going to be adjacent over hypotenuse. And then usually you want to get rid of the radical out of the denominator, so I can multiply by radical 2 over radical 2. And that's going to be radical 2. And then radical 2 times radical 2 is radical 4, which is 2. And then sine of 45 is opposite, which is also 1, divided by hypotenuse. And again, if I get rid of the radical from the denominator, I'm going to get radical 2 over 2. Okay, so that's like one special angle that you should know. 45 degrees, you should know what the cosine and sine are. And remember, 45 degrees in terms of radians is pi over 4 radians, right? So this is going to be, cosine will be radical 2 over 2, and sine is also radical 2 over 2. Okay, the other special ones, well, first of all, let's do 0 degrees, right? We said earlier at 0 degrees that cosine was equal to 1 and sine was equal to 0. Okay, that was by looking at the special unit circle. And 0 degrees is like right here. Let's say it's a unit circle, so this is 1. So these coordinates are 1, 0. And remember, cosine of 0 degrees is equal to the x value. So that was 1. And then sine of 0 degrees is equal to the y value. That was 0. Okay, so cosine of 0 is 1, sine of 0 is 0. And then 90 was the other special case where we're looking at this angle, right? This is 90 degrees, which is pi over 2 radians. And that has, if this is a unit circle, this has coordinates 0, 1. So now sine of 90, let me do cosine first. Cosine of 90 is going to be the x value, but that's 0. And then sine of 90 is going to be the y value, and that's 1. So this is the x value, that's 0. This is the y value, that's 1. So this is also true. Cosine of 90 is 0, and sine of 90 is 1. Okay, how do I do the other special one? So the other two special angles are 30 degrees and 60 degrees. Well, we can use what's called a 30, 60, 90 right triangle. Again, I think it's really useful to sort of remember this. So I'm going to draw this out. There's other ways of deriving it, but I think it's fine just to use this particular triangle here. So this is, say, 60 degrees. It's a right triangle, right? So this has to be 90 minus 60, so this is 30 degrees. The length of the short side, we're going to call 1. So we're going to force it to be 1. And it turns out, if that's the case, then the length of the hypotenuse is twice that, so it's 2. And then the longer leg, you could use Pythagorean theorem now, right? You could call it like b. So b is going to be the square root of c squared minus a squared. So it's the square root of 4 minus 1, so it's the square root of 3. But I just remember that. So if you have a 30, 60, 90 right triangle, short side is 1, the hypotenuse, the longest side is 2, and the long leg is radical 3. Okay, and this matches if you use Pythagorean theorem, that'll work out. So that means the cosine, let's do 30 degrees first. Cosine of 30 is going to be, so here's 30 degrees. It's adjacent, right, which is radical 3, over hypotenuse. So it's going to be radical 3 over 2. So it's adjacent over hypotenuse. So that'll be radical 3 over 2. And then sine of 30 is opposite over hypotenuse. So relative to the 30 degrees, what's the opposite side? It's the 1 here. So 1 over hypotenuse 2, it's just 1/2. Okay, then if I do the 60 degrees, so I have cosine of 60 is adjacent over hypotenuse. But now that's going to be the 1/2, right? Because now relative to the 60 degree angle, this is adjacent. That's the hypotenuse, so this is 1/2. And then sine of 60 is opposite over hypotenuse. And that's going to be radical 3 over 2. Because now relative to 60 degrees, this is opposite. This is hypotenuse, so radical 3 over 2. Okay, so now I can fill this in. This is radical 3 over 2, right? Cosine of 30. Then sine of 30 is 1/2. And then for 60 degrees, they reverse, right? So cosine of 60 is 1/2. And then sine of 60 is radical 3 over 2. And remember, if you're doing it in radians, right? Remember the corresponding conversions, right? 30 degrees is the same as pi over 6 radians. 45 is pi over 4 radians. 60 is pi over 3. 90 is pi over 2. And 0 is the same as 0. You could do those conversions if you forget, but that's another thing to know. So knowing this table is often useful. It just speeds up when you're trying to solve problems. Okay, last topic. Now we want to actually find the exact value for cosine and sine functions of any particular angle. And the easiest way to do this is to find the cosine and sine of the reference angle. And then it turns out that the cosine and sine of any angle will be the cosine and sine of the reference angle, except you have to correct whether it's positive or negative depending on what quadrant it's in. So that's the only difference. Okay, so first of all, let me remind you of what reference angles are. So every angle T has an acute reference angle between 0 and 90 degrees. Between 0 and 90 degrees. So if we're in, I'll just draw like unit circles here. If we're in the first quadrant, then the actual angle, right, which we call T, is equal to the reference angle, which I'll call t prime. So I'm going to say, let me squeeze this in here. So the actual angle is going to be t, and let's say the reference angle we're going to call t prime. So in this case, if you're in the first quadrant, the actual angle is the same as the reference angle, because the reference angle is the angle that the terminal side makes with the x-axis. It's always the angle that the terminal side makes with the x-axis. So the actual angle, remember the actual angle is starting at the positive x-axis and measuring counterclockwise. They're the same in that case, okay? What about the second quadrant? Well, in the second quadrant, my actual angle is like this. It's going to go from the positive x-axis counterclockwise, right? So that's my t. So what is the reference angle? Well, the reference angle is just the angle that that terminal side makes with the x-axis, which is this right here. So this is my reference angle, t prime. Okay, if I'm in the third quadrant, so somewhere in here, my actual angle will be this angle from the positive x counterclockwise. So that's t. But my reference angle is just the angle that that terminal side makes with the x-axis. So it's just this, back to the negative x-axis. Right? It's the angle that it makes with just the x-axis. In this case, is with the negative x-axis. And then finally, if I'm in the fourth quadrant, so something like this. So this would be my actual angle, t. And my reference angle is going to be the angle just that that terminal side makes with the x-axis right here, t prime. Right? So the reference angle is always an acute angle. It's always between 0 and 90 degrees. How do you find it? Well, it depends on what quadrant you're in, right? If you're in the first quadrant, so in this case, this is like the first quadrant, the reference angle is equal to the actual angle, right? There's no difference in the first quadrant. In the second quadrant, if I want to figure out what t prime is, well, if I start at the positive x and I go all the way over to here, this is 180 degrees. And if I subtract the actual angle, that'll give me the reference angle. So in the second quadrant, t prime is going to be 180 minus the actual angle. Or if you're using radians, it'll be pi minus the actual angle. So this is quadrant 1. This would be quadrant 2. Quadrant 3, how would I figure it out in this case? Well, remember, from here to here is 180 degrees, right? So if I take the actual angle and I subtract 180, that's going to be what's left over, which is my reference angle, right? So if I'm in the third quadrant, the t prime is equal to t minus 180. Or it's equal to t minus pi, right? If you're in radians, depending on whether you're in degrees or radians. And then finally, if I'm in the fourth quadrant, if I measure all the way around, that's going to be 360 degrees. So if I go all the way around 360 and I subtract the original angle t, what I'm left with is that reference angle t prime. So in the fourth quadrant, t prime is going to be 360 minus the actual angle. Or if I want radians, it'll be 2 pi, right? Remember, 2 pi radians is the same as 360 degrees minus the actual angle. Okay, so let's first find the reference angle for a few different angles. So if my original angle is 225 degrees, so what does that mean? Let me draw a unit circle. Well, I start here, right? I'm going to go like 180 and then I guess another 45. So I'm going to be like in the third quadrant. Like this. And I know that this angle is 225 degrees. And I want to find this angle. Okay, so how do I do that? Well, if I'm in that third quadrant, then I know that my T prime is going to equal my original angle minus 180. Right, so T prime in this case will be 225 minus 180, which is equal to 45 degrees. And that makes sense. So the angle that it makes with the nearest x-axis, right, when just the closest x-axis, is 45 degrees. So that's the reference angle. All right, what about 5/3 pi? If that's my original angle, what's the reference angle? So again, let me draw a picture. There's my unit circle. So what is 5/3 pi? Let's see. Well, 2 pi, right, which would be 6/3 pi, would be all the way around. So it's not quite all the way around. So it looks like it's going to be somewhere in the fourth quadrant. Right, so this angle right here is 5 pi over 3. And I want to find the reference angle, T prime. So if I'm in the fourth quadrant, then remember the way to get T prime, my reference angle, is to take 2 pi and subtract the original angle in radians. So what is 2 pi minus 5 pi over 3? Well, I better rewrite this with the same denominator, so I can write this as 2 pi is 6/3 pi minus 5/3 pi. So that's just going to be 1/3 pi, right, or pi over 3. So it looks like in this case that my reference angle is just pi over 3. So this angle right here is pi over 3. Okay, and this one over here was 45 degrees. Right, so you can always find the reference angle. It's just the angle that the terminal side makes with the x-axis. That's the way to think about it. Okay, why do we need to know this? Why do we need to know about reference angles? Because it turns out that the sine and cosine of the actual angle is the same as the sine and cosine of the reference angle, except you have to check to see whether it's positive or negative because it depends on what quadrant it's in. But it's always easier to find sine and cosine of a reference angle because it's sort of like just using the acute angle. It's almost like using right triangle trigonometry, right? So that's the key thing. The sine and cosine of the actual angle are the same as the sine and cosine of the reference angle, and you just need to correct whether it's positive or negative depending on what quadrant it's in. All right, so this will make more sense with some examples. So let's say I want to find the cosine of 150 degrees. Okay, so first of all, what is the reference angle, right? If I have cosine of 150, if this is my circle here, 150 is going to, so 180 is halfway around, right? So 150 is going to be somewhere in here in the second quadrant. So this is 150. How do I find the reference angle? Let me make that a little bigger. It's hard to see that. Okay, so 150 is somewhere in the second quadrant. This is 150. So this is the reference angle. And to find it, remember I can just say it's 180 minus 150. Right? It's like 30 degrees. So the angle that makes with the x-axis is 30 degrees. All right, so what I'm saying is the cosine of 150 is the same as the cosine of 30 degrees, except I'm going to have to check to see what the correct sign, positive or negative, is. All right, cosine of 30 is one of our special angles, right? You should know it. If not, go back to that table. It's equal to radical 3 over 2. So that means cosine of 150 degrees is also equal to radical 3 over 2, except I need to check what the correct sign. It could be positive, it could be negative. So how do I know that? Well, depending on what quadrant I'm in. What quadrant am I in at 150 degrees? I'm in the second quadrant, right? So remember, all students take calculus. So in the second quadrant, sine is positive and the other two are negative, which means cosine and tangent are negative. So in this case, cosine must be negative, right? Because I'm in the second quadrant. So that would be the answer. So it's the same answer as cosine of the reference angle, except I had to correct the sign here, right? It could be positive, could be negative, but because I'm in the second quadrant, the cosine is negative. So, all right, so in quadrant 2, cosine is negative, right? That's why I ended up putting a negative there. All right, what about the sine of 150? Okay, so remember the reference angle is 30 degrees. So I can start by finding the sine of 30, because it's going to be the same as that, except I just need to correct the SIGN, right? Whether it's positive or negative. Well, what's the sine of 30? That's one of our special angles, just a half. So now I can go to what I really want, sine of 150. It's equal to half, but the question is, do I put a positive here or a negative here? Well, I'm in the second quadrant. In the second quadrant, sine is positive, right? All students remind you that sine is positive. So this is the correct answer, right? It already, you don't need to write it, but you could even force it. Say there's a positive. It's positive 1/2. Okay, what about cosine of 315 degrees? Well, first of all, what is the reference angle? Because we want to find the reference angle. So 315 is kind of going to be in the fourth quadrant, I guess. Yeah, it'll be, let's see, I guess it'll be this one, right? So this is like 315. So what is the reference angle? Well, that reference angle, T prime, I can figure it out by doing 360 minus 315. And that's equal to 45 degrees. All right, so now I can work on my actual problem. I want the cosine of 315. Well, it's the same as the cosine of the reference angle, which is 45. And we know that that's one of our special angles. It's radical 2 over 2. So cosine of 315 will also be radical 2 over 2, but I might need to correct it, right? Whether it's positive or negative. So I'm in the fourth quadrant. What's true about cosine in the fourth quadrant? Well, all students take calculus, right? Or what was the other mnemonic? Add sugar to coffee, right? Coffee or calculus. That reminds you that cosine is positive in the fourth quadrant. So this is positive radical 2 over 2. So that would be the answer. Okay? And then we can do the same thing with if the angle is in radians to begin with instead of degrees. Sometimes, honestly, I think much more quickly in degrees, and I just convert the radians to degrees. But that might be the best way to do this. So, first of all, if we're talking about cosine of 5/3 pi, right? Remember, 2 pi is a full rotation, so this is not quite a full rotation. So I guess in this case, we're going to be in the fourth quadrant. So this angle right here would be 5/3 pi, right? Because 3/3 pi would be like 180 degrees halfway around, and then we're doing 2/3 of the way around again. So to find this angle, which is what I really want, T prime, I have to do 360 degrees or 2 pi radians, because I'm in radians, minus 5 pi over 3. So this is like 6 pi over 3 minus 5 pi over 3. And that's going to be pi over 3 radians. Okay, I think more quickly in degrees. So what I would do is convert that to degrees. It turns out pi over 3 radians is the same as 60 degrees, right? You could multiply. This is another one that you want to know. Some of these you want to just know or write them down into a table that you can quickly refer to. So if you use like a cheat sheet on one of my exams or something, these are the things you want to just put down. So I could multiply by 180 over pi, right? To convert it. Then the pi's cancel, and then 180 divided by 3 is 60 degrees. So that's the same as 60 degrees. So cosine of 5/3 pi is the same as cosine of pi over 3. Because remember, it's going to be the same as the cosine of the reference angle. But this is cosine of 60 degrees, because I think more quickly in degrees. What is cosine of 60? That's one of our special angles. It's a half. So therefore, I know that cosine of 5 pi over 3 is also going to be a half. But then I have to figure out whether it's positive or negative. Well, I'm in the fourth quadrant. And what's true about the fourth quadrant? Cosine is positive, right? All students take calculus. Or add sugar to coffee, right? The C reminds you that cosine is positive in that fourth quadrant. So it looks like cosine of 5/3 pi is equal to 1/2. Okay, and then sine, same idea, right? We already know that the reference angle is pi over 3 or 60 degrees. So I can just find the sine of pi over 3, which is the same as the sine of 60 degrees. That's one of our special angles. It's radical 3 over 2. So now I want to find what I really want, which is sine of 5 pi over 3. So it's going to be radical 3 over 2, but I just need to check whether it's positive or negative. Well, again, I'm in the fourth quadrant, so cosine is positive, right? All students say calculus. That means the other two, sine and tangent, are negative. So this must be negative then in the fourth quadrant. So in quadrant 4, sine is negative. So that would be the answer. So sine of 5/3 pi is equal to negative radical 3 over 2. Okay, so one more example here. In this case, sometimes you have to think about like how to get the actual reference angle, right? In this case, we want sine of negative pi over 6. Well, remember, negative means to rotate clockwise. Okay, so that's going to be like in the fourth quadrant. This angle right here would be negative pi over 6. Now, if you think about it, that pi over 6 itself must be the reference angle, right? Because that's the angle that makes with the closest x-axis. But if you want, you could find the coterminal angle first, the angle that's between 0 and 2 pi. You could find that first. So here, let's just do it that way. Find coterminal angle. The one that we want between 0 and 2 pi radians. Well, how do we do that? Remember, we have to keep adding 2 pi until we get a value that's between 0 and 2 pi radians. But in this case, that's not bad. It's going to be negative pi over 6 plus 2 pi. So that's negative pi over 6 plus 12 pi over 6. And that's going to equal 11 pi over 6. Okay, but then how do I find the reference angle? Well, I'm in the fourth quadrant, so to find the reference angle, t prime, I have to take 2 pi minus the actual angle, which is 11 pi over 6. And that is going to give it, so this is 12 6 pi minus 11 pi over 6. It's going to give us what we expected. It's just going to be pi over 6, but positive. Okay, so since I rotated clockwise, right, negative pi over 6, the reference angle is just the angle that that terminal side makes with the x-axis, which is just pi over 6. Okay, so now we can say that sine of negative pi over 6 is the same as sine of pi over 6. Right, it's the same as the reference angle. I don't like working in radians, so I'm going to convert that to degrees. Pi over 6 is 30 degrees. So this is the same as sine of 30 degrees. And that's equal to 1/2. So now I know that sine of my actual angle, negative pi over 6, is equal to 1/2. And I just have to figure out whether it's positive or negative. Well, I'm in the fourth quadrant, right? Because the actual angle is negative pi over 6. And I know the mnemonic, all students take calculus, right? Or add sugar to coffee. So in the fourth quadrant, cosine is positive. The other two are negative. So in quadrant 4, that means the sine is negative. So this is going to be negative 1/2. And that would be my answer. So sine of negative pi over 6 is equal to negative 1/2 because I'm in the fourth quadrant. Okay, so it takes a little practice, but eventually you'll get good at figuring out the cosine and sine, and you could even go further and do tangent and the other trig functions, but we focus mostly on cosine and sine of any angle by first finding the reference angle and finding the cosine or sine of that reference angle, and then just correcting it by figuring out what quadrant you're in. Okay, great. There's one more section that we're going to do in this course. It's applications of trigonometry, and it's section 10.8, which is on vectors. So this will be important, especially if you're going to be taking our physics for movement science course. Then you're going to have to at least be exposed a little bit to vectors. Great, thanks.